The next topic that we're going to talk about is constant growth annuity. So previously, we assumed that the periodic payment is constant over time, but in real life, often the periodic payment changes, and this is what we're going to cover right now. For constant growth annuity, our periodic payment changes at a constant rate. And what that means is that our periodic payment, our PMT, changes, so it increases or decreases at a constant rate K. So the constant rate that we're saying is that it changes at a rate of K per period. So the K is for per period. So every period, it either increases at a constant rate of K or it decreases at a constant rate of K. And we have a bunch of formulas here. We have the size of the nth payments. This is the formula that we use to find out the size of a specific payment for a specific period. And then we have the sum of the periodic constant growth payment. This is the formula that we use to find out the total payment or total deposit. So before, what we learned is that if payment is constant, then our total payment is the payment amount times the number of period. So this was the formula that we used to calculate total payments when the payment amount is constant for each period. So the payment amount is the same for each period. But with the constant growth annuity, our payment increases or decreases every period. So therefore, to calculate the total payment, we use this formula here, and then we call it the sum of the periodic constant growth payment. And that's just the formula that we use to calculate for total payment for constant growth annuity. And then we also have the formula here for future value and present value. And for constant growth annuity, we have to solve it algebraically. We cannot do it in the financial calculator. And the reason we're learning this is because the constant growth annuity is a more realistic assumption in real life. In real life, our payment is not going to stay constant. Our payment is going to change over time. So that's why you need to know about constant growth annuity. So right now, I'll show you example 2, and I'll show you how to apply that. Example 2, withdrawal increasing at a constant rate of 4.6% are made quarterly for 3 years from an account earning 6.2% compounded quarterly. Part A, what must be the balance in the account to permit the withdrawal if the first withdrawal is $900? So our first step is drawing the timeline here. So we know that we're making a withdrawal, which increases at a rate of 4.6% per period, and we're doing it for 3 years quarterly. So that means our n equals to t times py, because we have payments, so n equals t times py. So we have 3 times 4, so 3 years times payment per year is 4 times a year, so our n is 12. So we have a total of 12 payments. In the diagram here, we have n, number of payments, starting from 0 all the way to 12. And we're given that our first withdrawal, our first payment is $900. So that's why at period 1, at the end of the first period, we have $900, and that's our PMT. So your PMT is your first payment. And we know that the payment amount increases at a constant rate of 4.6%. So that means at period 2, our payment is not going to be 900. Our payment is going to be 900 times 1 plus the 4.6% to the power of 1. So we're going to get 941. And that's our payment for period 2. And then same idea for payment 3. So we take the 900, we times it by 1 plus 4.6%, 1 plus the K. So we times it by 1 plus the K, and then to the power of 2, and so on until we get the 12 payments. So in this diagram, we have the number of payments, we have 12 payments, and then we have the PMT amount. And the PMT amount is increasing at a rate of 4.6% per period. And this is what we have illustrated here. And that's what you need to know from a timeline perspective. And in the question, what we're solving for is the balance in the account to permit the withdrawal. So in part A, what we're solving for is the present value. We're looking for how much money we need to have today to allow for this withdrawal. So we're looking for present value in part A. So for part A, we're going to use the present value formula. So this is the formula that we're going to use for part A. We're going to use this formula to calculate the present value. And in the formula, our PMT is 900. Our K is the 4.6%, and then I is the periodic interest rate. So I is not your nominal interest rate. I is your periodic interest rate. That's your periodic interest rate. So that's what you need to understand. I is your periodic interest rate. So in order to solve for part A, we need to first find out the periodic interest rate. So periodic interest rate is your nominal interest rate divided by your compounding per year. So we have 0.062 divided by 4. So 0.062 is your IY, and then C over Y is your 4. So we divide those two numbers, you can get 0.0155. And that's your periodic interest rate. So once we have the periodic interest rate, then we can substitute that into the formula. So we have the 900 as your PMT, and then we have the K. K is your 0.046, And then we have your I is your periodic interest rate, so 0.0155. And then our N, our number of period, is 12. And if you solve for the present value on your own, you're going to get $12,580.33. And that's part A. Part B, what we're looking for is the size of the last payment. So the size of the last payment is the 12 payments. So our last payment is the 12 payments. And to find out the size of the last payment, this is the formula that we're going to use, size of the nth payment. So it's the size of the last payment. So PMT times 1 plus K to the power of n minus 1. So PMT is 900, K is your 4.6%, and then n is 12. So we're going to plug that in. To find out the size of the last payment, we have 900 times 1.046 to the power of 12 minus 1. So basically what we have is 900 times 1.046 to the power of 11. And how you do this on the financial calculator is you type in the 1.046 first, and then you put it to the power of 11. Then you times it by 900 afterward. So we're going to start with the 1.046 to the power of 11. How we do that on the financial calculator is 1.046 to the power of 11. So to the power of 11, this is on the financial calculator is your y to the power of x. This is the notation for power. So we're going to press y to the power of x. And then we're going to press 11. And then we press equal. And then this will give you 1.046 to the power of 11, which is 1.64. And then once we get the power, then we times it by 900. And that will give you the size of the last payment, which is 1476. So again, to the power of 11, this is what we use. We click y to the power of x. And that's the button that you need to click, y to the power of x. Part C, what we're looking for is the total amount withdrawn. And part D, what we're looking for is how much interest is included in the withdrawal. So to find out part C, we're looking for the total amount withdrawn. So we're looking for the total payment. And the formula for the total payment is the sum of the periodic constant growth payments. So we're going to use this formula here to find out part C. So part C, sum of payments. So we have 900, that's our PMT. And then we have the 1 plus K to the power of 12 minus 1 divided by K. And when you plug that into the financial calculator, you're going to get 13998.10. And how you do it algebraically on the financial calculator is you type in what is in the bracket first, then you times it by the 900 afterward. So I'll show you that. So what you do is you type the 1.046 to the power of 12 first, and then you minus 1. So we're going to do that. So you do the numerator first in this case, so 1.046. So to the power of is your y over x. And then you press 12. And then you put equal, and that will give you the 1.046 to the power of 12, and then you minus 1. And then you divide it by your k, so divide it by 0.046. And then once you do that, then you times it by 900. And that will give you the 13998.10. And that's part C. Part D, we're looking for total interest. So total interest is basically your total payments minus your present value. So we made a total withdrawal or total payments of 13,998. That's our total withdrawal. And what we put in at the beginning was $12,580. So we subtract those two, and that will give you the 1417, and that's our interest. So your interest is basically your total withdrawal minus what you put in at the beginning. The difference between that is your interest earned. And that's 1417 is the answer for part D.